Okay, so last class you guys performed your skits on how you thought um, computers can find websites even though they don't know the IP addresses of the websites. They only know the names of the websites. And some of you guys said that you thought maybe this information was contained in the computer itself. When I say information, I mean like a giant phone book or a database that has all the website names like facebook.com or google.com, and right next to it the IP address that goes with that website. So some of you guys thought that this big phone book is inside the computer itself, and so that whenever the computer needed to go to a website name that you gave it, it would immediately look inside its own phone book and then go to that IP address. Some of you thought that maybe this big phone book was kept in a faraway place, like a satellite or a big special server with uh, aliens running it or whatever. And so basically, with those two possibilities, we can look at how it really works. So if you look at the first option here, it says the first option, which was that the computer already has this phone book inside of it. And that was the way the internet was at the very beginning. There weren't even websites back there. The only reason why computers had to know the names and addresses of other computers was to send email, and it didn't have that many servers that it had to keep track of. So these little phone books were updated by hand, or replaced with another file, and of course they were always out of date because whenever a new server popped up, since they were updating manually, they never kept up. And then the other idea that you guys had was that the big phone book was kept by some server out there, like in a satellite or whatever. Well, I mean, the satellite part is, of course, wrong, but the rest of it's right. I mean, there is a big server out there which has this big phone book, and that's the way we do it today. Whenever your computer has to go to a certain website name like facebook.com or google.com, it sends a message to this big server, and it asks the server for the actual number address of the server. And then once it gets the number address, the IP address, then it sends another message to the IP address. So the only variation is that there's kind of a bunch of different servers like this. There's the big important ones, and then there's less important ones. And also, the computer can also remember some of the addresses, some of the recently used addresses it remembers, so that it doesn't have to ask every single time you type an address that you use frequently. It'll remember those. So in a way, the way today's computers work is the first option that you said, where the computer actually has its own little phone book, and it does. Okay, so this little phone book that the computer keeps of the recently used addresses is called a cache, which is a small, quick memory which the computer keeps so that it doesn't have to ask for sites that it already knows that you visit a lot. DNS is another term that we should remember. It stands for Domain Name System, and it's just the servers or the process which the names are decoded into addresses. So this is a diagram of actually how it works. And in addition to the computer having its own cache, you can see here, if you type www.wikipedia.org into your computer, first thing it checks is the IP address already in the computer's cache? And if it's not, then it's going to ask the internet service provider's DNS. Who's the internet service provider? Well, in Campinas, it's either Net or Speedy, and it's going to ask a server at that ISP, and then that computer stores all the IP addresses that that customer's group have been accessing. So it might be there. I mean, really popular sites are definitely going to be there. Now, what if nobody has accessed wikipedia.org for a while? Then it's not going to be in the ISP cache either. And then the DNS is gonna, the ISP's DNS is going to ask a bunch of other big servers, like worldwide servers. And so the first one it's going to ask is the root name server. And this, if this big server doesn't know the IP address of wikipedia.org, it's going to say, well, I don't know wikipedia.org, but I do know a server that knows all the .org site IP addresses. So it sends that address, and then you ask the .org name server, and then the .org name server is going to know the address for wikipedia.org. Okay? And if wikipedia.org has a bunch of servers inside of it, then maybe they have to ask the wikipedia.org name server. But the basic idea here is that know that first the computer checks itself to see if the address is already in its own little cache, and if it's not, it asks the internet service provider's DNS cache, and if it's not there, then the DNS cache is going to ask these other DNS servers. Okay, and so as far as root name servers, we talked about this big server which handles DNS. There are 13 in the world, 10 in the US, 1 in Japan, 1 in London, 1 in Stockholm. So most of them are in the US. Now, why are there so many? They all have the same data. Why would you need 13? Well, we talked before about computer redundancy, where if you have a problem with the computer and it goes down or gets blown up or whatever, what's going to happen? Well, you still have others. The other reason why you would have many of them is because the internet's a big busy place, and maybe 1 or 2 servers is not enough. You want to have many servers. Why would you have one in Japan instead of just all in the US? Well, you know, these messages take a long time to go from one place to another if they're on the other side of the world. You want to have the servers as close as possible to the customer. Okay, then we're going to just talk a little bit about Wi-Fi. You know what a hotspot is. A hotspot is a place where you can connect up to your Wi-Fi. Now, when we talk about how many hotspots, you might see that the hotspot is named the same thing, but there are multiple little areas that are being covered. Each one is covered by a separate antenna. So when we say hotspot, we might be talking about an AP or an access point, which is an antenna which covers a little area, or in our house, sometimes we say a Wi-Fi router. So these are all kind of synonyms, meaning a little area that's covered by one Wi-Fi access point. Okay? It might be confusing because if we talk about EAC, you say, oh, EAC has a hotspot, it's called EAC Wi-Fi. Well, EAC actually has several hotspots, and they're all called EAC Wi-Fi. So next thing we're going to talk about is Wi-Fi security. There's 2 kinds of security that you have the option to choose on your Wi-Fi router at home. One is WEP, WEP, and the other is WPA. And what you want to do is always choose WPA as long as your internet devices are all pretty modern enough to be able to use WPA. For example, one device which cannot use WPA because it's too old is a Nintendo DS. A Nintendo DS can only access WEP. But the problem with WEP is, as it's the first security version made when they invented Wi-Fi, they made a couple mistakes on it. It's too easy for hackers to figure out what the password is and to break into your Wi-Fi and use your Wi-Fi, and worse, watch everything you're sending on it. So the problem with WP is that it uses the same code all the time to hide the information. And if a hacker sits there watching all these messages, eventually he can figure out what the code is, because the code ends up kind of leaving a trace on all the coded messages. So you can reverse generate the code from all the coded messages. Now WPA improved on that because WPA used a scheme where they constantly change the code. So once you're using the Wi-Fi connection, your code is being changed frequently, so the hacker can never figure it out. Now, when you access, you're always going to use the same code, but they try to make it so that the information sent with the access code is only used during access, so it doesn't give enough opportunity for the hacker to get enough information to decode the code. So normally WPA is not breakable, but if you happen to use a pattern of letters in your password that is not what we call random, then it becomes possible for the hacker to figure out the Wi-Fi password, even though you're using WPA, because it severely limits the number of possibilities if you use what we call dictionary words. So if you use a word for your code instead of kind of a random string of letters, then there's like a pattern there, because our language uses consonants separated by vowels, for example. So you don't have a bunch of consonants in a row. And a hacker can use that fact to, if he sees a consonant, then he knows the next letter might be a vowel or whatever. So he can really limit the possibilities of codes, and then he can guess the right one. Now SSID is the hotspot name, and so remember I said that EAC has several hotspots, and although all the hotspots are called EAC Wi-Fi, the same name, or SSID, it's actually several hotspots because it's several antennas. And EAC's antennas are pretty fancy. They can carry multiple names on the same antenna, so we can see EAC Wi-Fi, EAC car pickup, etc., all on the same antenna. Okay, so that was it for this video.